Hi, everyone. Welcome to my talk here, Livin, Vida, Locomotive. I'm going to talk to you all a little bit today about my adventures in hacking locomotives. Mostly this talk is going to be focused on some of the gaps and how you may be able to mitigate those gaps without getting into ugly, dirty details. So I will give my little bio here. I'm currently a technical director of Linux runtime threat detection at Sophos Labs. Previously, I worked at Dragos as a principal penetration tester, which is where my experience comes from on this topic. Spent a couple of years hacking locomotives for various clients and had a really good time doing it. Prior to that, I was working for the US intelligence community. So I also have some background in intelligence collection and analysis. So it kind of plays a role, but not as heavy a role as my most recent experience does. So what you're seeing in this slide is maybe a little bit confusing. This is a meme. And the main content here is the right side. So the Siemens American City Sprinter 64,000 kilowatt. This is a very interesting locomotive used all over the world. Lots of locomotives very similar to this one, but this is a beloved piece of hardware. My talk is not going to center specifically on this one piece of hardware, but there are lots of systems inside of the Sprinter that overlap with different locomotives around the world. Depending on who produces the hardware, you may see different things. So the Siemens Sprinter is probably one of the more common that you will see in the United States, but the Siemens production will have a lot of these similar systems. Is kind of the main goal here of this topic. And so moving on to the next slide, if it goes. Okay, recent news. So I wanted to start off by talking a little bit about some of the most recent things to happen in locomotive cybersecurity. So in December of last year, the Biden administration did release some guidance on cybersecurity for rail. Wanted to put this right up front so that it's well understood that a lot of the issues that I'm going to be bringing up here are currently being addressed by the Biden administration's rail cybersecurity objectives. So not to worry if you're a passenger or if you entrust your freight to a freightliner in the United States. A lot of those, in fact, all of them, it's mandatory. So all of the rail operators in the United States are going to conform to a certain set of standards. A lot of these things, I would personally recommend has to do with monitoring, designating cybersecurity coordinators, that sort of thing that we would recommend across the board to all ICS operators. So there's really good developments happening in terms of regulation and law legislation. So let's first talk a little bit, when we get into the technical topic, let's talk a little bit about what a locomotive is and how we would define it. So one of the most interesting things from an ICS practitioner standpoint about locomotives is that they are basically like any factory that you may walk into anywhere in the world, except that they are on wheels and they do in fact move. So they move very fast and hundreds of miles per hour. So they are certainly one of the fastest moving ICS networks that you're going to find on the planet. Of course, airplanes fly and use ICS as well, so it doesn't quite compete with that. A lot of substantial differences in ICS on a locomotive versus versus an airliner, though, I imagine. So having to cram all of these ICS components into a very small space and making it movable means that all of these components have to operate in tandem and usually have to fit a fairly small form factor. So they also have to be manageable. So if something needs to be replaced, or if there needs to be a period of maintenance, then there's going to have to be some amount of ease of operability in terms of swapping those things in and out and controlling changes. All of those things have to be taken into account. These things are often in and out of shops, so for various reasons unrelated to the ICS components. But one of the other things that I think is really interesting about locomotives in particular is that they have to stack a couple of different types of systems on top of each other. So what we might see in a factory in terms of where the digital, like the cybersecurity digital footprint comes in, is like a digitally managed arm for moving something on and off of a conveyor belt or a timer, for instance. A lot of the same systems apply to locomotive, except for a lot of these are also like electromechanically controlled. So your braking systems, your propulsion systems, which are two of the main operating functions of your locomotive, all of those have to somehow integrate with a digital footprint. And because of the size and scale of the locomotive, they often don't interoperate cleanly. So you kind of have to find ways to interchange them that are completely, this is on the vendor, by the way. The vendor has to find ways to interoperate these things, and oftentimes they are solutions that work but are not necessarily elegant, which is why we have to really take into account what the owners and operators do with this equipment once they get it. So in terms of custom configurations, making sure that all of these things work and are understandable when they come in for maintenance, all of that is very, very important from an IT perspective or an operations perspective, but even more important from a cybersecurity perspective. So I've included a couple of funny slides in here, so just bear with me. I know it's the end of the day and I'm sitting between you and freedom. But I wanted to give you all some lessons that I learned from the rail yard. So the first lesson of being in the rail yard is never walk between the train cars. Walking between the rail cars may seem like a really good idea to get from one place to another, but it's a really, really bad idea. If a train moves in the wrong way, you get crushed, you're probably going to die. It's probably going to kill you. Okay, so physical security wise, the physical security is always important when it comes to cybersecurity, but it's even more important when it comes to locomotive security. Why is that? Well, because all of your systems that you need to protect are essentially encased in the locomotive. So if somebody is able to just open the door for the locomotive and climb up in there, they have the right kind of connector. They have maybe just a little tiny bit of knowledge about what's going on inside of the locomotive. Very easy to get in there and start messing with things, and actually putting things in place that will compromise the security of a locomotive long term. So not just while they're inside of the locomotive, but things that may be able to call back over a radio or something, which I'll get into a little bit later. So these systems are very susceptible to physical attacks. There's a reason that they put locks on the doors. They should definitely be used. And the other thing too to remember about locomotives is a lot of times they will take the locomotive and kind of like put it out in a section of rail, which I've seen many times, and just kind of leave it there for extended periods of time, whether it's between crew changes or if it's just waiting on a siding somewhere. Unattended locomotives are fairly common. What is also fairly common is people getting into rail yards that shouldn't be there. So the physical security aspect really needs to be paid attention to instead of kind of like just dismissed as one of those things that, yeah, of course we do physical security. Really, really important from a cybersecurity perspective here as well to make sure that that's being done properly. So if you were to get physical access to a locomotive, you'd be looking to connect through a couple of different ways that I've noticed. One is with these M12 connectors here. So it's just a ruggedized IP network. The barrel connectors are fairly common, but also so are Ethernet connectors. So those are becoming more common. But on older locomotives, you're more likely to see like an M12 or a barrel connector. So if there was any concern about like how you might connect to one of these things once you get access to it, it's a fairly small number of ways. But I imagine that over the years, it's going to integrate closer to a standard. So it's probably going to integrate closer to a Cat5 or Cat6, some kind of Ethernet and terminator. So talking about some of the sensitive components that we'd be looking at here from a cybersecurity perspective, we'd be looking at things like operator displays. We'd be looking at train routers, radio systems, positive train control, traction control, and central control. So this is kind of vaguely split up into two different categories, and I've just now noticed this. I didn't do this on purpose. The top layer there are things that kind of interface with your train operator in one way or the other, or they facilitate communications. So your operator displays are what your engineer is actually going to touch the buttons and IO with the locomotive hardware itself. Your train routers are going to be the kind of middleman between your radio systems and what's going on inside of the locomotive. So those systems that are built into the locomotive have to communicate in its own little local area network, but also out over the radio systems. The radio systems are just fancy LTE systems for the most part. They are just cellular systems that are made. They're there to facilitate communication between all of the different reporting mechanisms that the locomotive has to send back for regulation and just general management of the locomotive. And then we can start to get into the more critical parts at the bottom, like PTC, traction control, and central control. Now, traction control and central control are fairly similar. The traction control makes the train go, and central control, traction control controls whether the train goes or stops. Central control manages all of those inputs between the train operator's digital systems and its electromechanical systems. So both of those tend to be somewhat squishy targets in digital systems. A lot of these things are using FTP. So if you have like a file transfer presence on your locomotive, which many do, you're going to want to check those and make sure that you have, like good password policies are being enforced. A lot of this basic stuff that we would say are no-brainers in IT, or just even in other more mature or more long-standing areas of digital cybersecurity. A lot of these things that we would consider to be like, well, yeah, of course. Just make sure that those are being done if you're a rail operator, and also build up some policies that help guide how your maintenance folks do this. This is very easy to overlook, and it's also very easy to lose those passwords and then just change it because it's easier that way. The last one I want to touch on real briefly here is positive train control. This one is a bit of a bear to cover. And it was kind of difficult for me to figure out how to cover PTC because it's maybe one of the most critical systems on the locomotive. PTC stands for positive train control. And what PTC does is it manages whether the train stops or goes from a sort of regulatory perspective. So a lot of locomotives have an acknowledge button in them. So if you're an engineer, this thing beeps every 30 minutes. You have to physically touch the acknowledge button to let the system know that you are not sleeping. So once you hit that button, it resets the timer and you can continue with your motion. This thing is really annoying. When it starts to go off, it beeps incessantly, very quiet, and then much, much louder, and you can't ignore it. So you are either unconscious or you're dead or possibly deaf. You have something going on that makes it so that you don't know that this tone is occurring. And that's just one element of PTC. So with positive train control, if you don't hit that button, it will actually slow the train. It will bring the train to a stop eventually if you don't acknowledge. So PTC is really important for the continued operation of the locomotive, but it's also a very sensitive component. It's very sensitive to things like timing. It's very sensitive to a light breeze may blow this thing over. PTC is one of these areas that I highly recommend that not only rail operators pay attention to, but also maybe something that that government bodies may want to take another look at PTC and make sure that it's got the type of resiliency built into it that makes it so that PTC is not necessarily a weak link in the way that we expect locomotives to be operating. It's a fairly robust and good, well-built system, but it needs to be, from a cybersecurity point of view, it could stand to be a little bit more resilient under pressure. Okay, the second rule of being in a rail yard: don't step on a rail. I know it's tempting. I do it all the time when I'm not working, but if you're in a rail yard, do not step on a rail. Why? Because the rails have this coating of grease on them occasionally, and the grease could get on the bottom of your boot. You could slip directly under a locomotive. The locomotive will crush you. If you step on a rail, you're probably going to die. Central computing. So I kind of briefly touched on central computing. Central computing is a system that interfaces the locomotive engineer, their digital systems, to the electromechanical systems. So these systems are typically based on some form of Unix, at least in my estimation. I've seen a lot of BusyBox. So BusyBox is pretty well spread throughout the industry. Very lightweight, very easy to deploy. Also has a lot of vulnerabilities. So this is often running some form of file transfer as well. You have to have some form of maintenance, some way to maintain configurations on the central computing. So again, this can be made much more difficult, much more resilient through standard good password policy. But also architecture is another good way of securing central computing. Lesson number 3, do not touch the catenary wire. It's pretty high up, going to be hard to get up there to touch it. But if you touch it, those things have electricity going through them. It should be standard knowledge that any wire above you is not to be touched. But if you're standing on top of a locomotive or something to do work, you need to make sure that you are far clear of the catenary wires. Why? Because there's a lot of electricity in them. If you touch one of those catenary wires, you could fall off of the train, and you're definitely going to die if you touch a catenary wire. Radio systems. So radio systems are one of these things that actually pose a fairly traditional risk profile in comparison to IT systems. So you're using radio systems, obviously, to communicate off of the locomotive. The rail systems generally use some form of LTE because they're high speed and fairly good coverage. These things can also be vectors for traversing vertically through north-south through the locomotive. So if you have a compromised radio system or a system that's been compromised, you can use the radio system to achieve off locomotive connectivity. Again, this just goes back to like good architecture, making sure that your radio systems are isolated in one form or another from the rest of your systems. Very important to make sure that these radio systems are well maintained, up to date, that they are regularly maintained. This is the one aspect I think of any system that I ever saw in locomotives that actually presents a very traditional cybersecurity risk to a locomotive. So I only mention it briefly just to kind of like point out that even though there are some systems that would be considered ICS specific, this one is fairly pervasive in various forms of technology. Train routers are also fairly pervasive in terms of just broader technology, but train routers are also very, very specific in what they do. So every system, whether it's on the local area network or coming through a wide area network in some way, is going to have to traverse through some form of router, and possibly more than one router. So depending on the configuration of the rail operator, you may have a train router that is centrally managing all of your incoming LTE radio and incoming and outgoing. You may also have one network that's set up to use a specific train router, maybe managing all the local systems, and then a separate one that manages your radio operations. I've also seen them deployed in ways that that protect crash recorders inside of locomotives. So they may have like a dedicated router just for that system, because that one is also fairly important to maintain in terms of knowing what happens in the aftermath of an accident. So these things actually are deployed and not touched very often from what I've seen. You could put a train router into operation and not do anything with it for maybe 10 years. And the other thing about this technology too is that they often end up on public marketplaces. So eBay sells a lot of these types of technologies. If you wanted to buy a train router and develop an exploit for that particular type of router, fairly easy to do. And fairly cheap as well. So keeping these up to date and again, maintenance architecture, I hit on this all the time, but it's really important to make sure that these things are hardened to the extent that they can be inside of your locomotive infrastructure. The fourth lesson here is respect the bells. If you hear a bell inside a rail yard, it's a locomotive is moving. There really not a whole lot of other applications where you would hear a bell happening inside of a rail yard, especially if it's a very loud bell. So if you're hearing a bell, you need to look one way, you need to look the other way, and make sure that you are not in the path of an oncoming locomotive. If you're in the path of an oncoming locomotive, it's probably going to kill you. So I always include, when I talk about pen testing ICS, at least a slide or two about impact, because that's ultimately what this is all about. So disrupting movement is one of these things that we have to take as an expected outcome of a successful breach. So what happens and how can we disrupt movement of a locomotive? Well, I've kind of already alluded to a couple of these. Your positive train control is one of those that could potentially disrupt movement, but also there are ways to disrupt movement that don't necessarily involve a purely technical solution to stopping a locomotive. Locomotive engineers are trained to follow a specific set of standard operating procedures. If they experience a loss of view, as in you compromise a train operator display to the point where it does not report information, your engineer may have to bring the locomotive to a stop on an active railway to deal with that. And that obviously has some safety implications, but it also has implications in terms of how you're going to run your business for the day. If you have a locomotive stopped on a main line somewhere and there's no way around it, that's going to really throw a wrench in your schedule. So there are a few ways that you could potentially disrupt movement for short periods of time, but experiencing long periods of outage is much more difficult to achieve in my experience. So normally what you're going to see is what you would see in a lot of other ICS environments. If you're experiencing an impact, is the engineer is going to kick off of the automated, like they're going to stop moving, they're going to bring the locomotive down, and then they're going to bring it back up and basically just like hard reset the entire locomotive. So it's a fairly standard response to experiencing something like a loss of view or a loss of control. Traction control. So with the movement of the locomotive, you essentially have two functions happening here. You have the wheels, making the wheels move and making the wheels stop. So impacting movement in one way or the other can disrupt a movement. If you're taking if you're applying a brake, or if you are compromising a system that obviously brings the locomotive to a stop, either through some standard operating procedure needing to be done or through a more technical means, you can disrupt movement that way, obviously. Or you may be able to tell the system to go faster. That impacting traction control is actually relatively difficult to do, especially from an external to the locomotive sort of viewpoint. So through an exclusively cyber means of command and control, traction and central computing are fairly resilient systems to disruption in this way. So just want to sum things up here because my time is running out. We depend on locomotives to get us where we want to go. We depend on them to get our things where we want them to go. The security footprint of locomotives is fairly robust. It's relatively difficult to compromise your way onto a locomotive without physical access. But if you do have that physical access, it's fairly easy to compromise from a cyber aspect. So as rail operators continue going down the path of digitizing their hardware, their train hardware, it's important to remember the basics with securing your infrastructure, making sure that you're changing passwords, architecting them so that there are no areas where the networks overlap, keeping all of your most essential, least resilient functions on a totally separate network. All of those things are critical to making sure that your cybersecurity is being done in a way that will minimize the amount of breaches and the severity of breaches that you may experience in the future.